All right. Well, hope you had a good weekend. A little bit better weather lately. Supposed to be like 78 today. That's kind of crazy, but I'll take it. So, for those of you who watched the Super Bowl last night, what was the best commercial? I had family over. We headed up there. We kind of paid attention here and there. We were more or less just visiting. Didn't really care a whole lot about either team. So, I was just wanting to see. Turned out not to be a real good game, really. It was kind of a walk away game. But surely there are some of the commercials that you liked in there. If you watched it, I'll be looking up some of the commercials lately because with all the talking and chattering, we couldn't hear everything on the commercials. So we'd stop if a commercial got our attention. But it's more Super Bowl's more about visiting and have fun, get together. I do enjoy. Was it Matthew McConaughey's commercial about they're trying to make all football is about food? Is that like a DoorDash commercial or something? I think those are pretty clever. Those are pretty clever. He's saying that football is just about selling food. It's not about the game. Reagan didn't watch any of it. That's right. You didn't miss much. I know. Apparently, I don't guess it's a bad idea. The NFL's thinking about adding one more game to the season. Right now, they have a 17-game season, which is kind of odd. They're looking to make it an 18-game season, and where it would push everything back 1 week. So the Super Bowl would be next weekend, which would mean it's followed by a holiday next Monday, because next Monday we don't have school. It's a holiday nationwide. It's a federal holiday, and so there's no school. And because all the statistics say that today there will be like millions of people across the country calling in sick after the Super Bowl. Every year it happens. They stay up, they get together and party, and they probably drink or something. Where they just don't get up and go to bed the next day. So this is like National Call-in Sick the Work Day. So they're thinking if we move the Super Bowl back a week, where it's just automatically a federal holiday where a lot of people already have the day off, that it could help the economy. I don't know. Maybe. I don't know. It's a thought. We'll see. But the players right now are like, oh, we don't want another game. But they're talking about taking away a preseason game and adding another game. I don't know. 17-game season just seems weird, though. So a prime number even. So whatever, they'll figure it out there. But all right. But yeah, there's always some good commercials in there. There's always some lame commercials. Pepsi tried. I didn't even like the Pepsi commercial. They're trying to show that the polar bears prefer Pepsi instead. It's like, no, nobody believes that. Nobody believes that. I mean, Pepsi, they need to advertise, really, because they are now the fourth most popular soft drink in the United States. Fourth. They were second forever. Coke has always been number one forever. And Pepsi used to be the second. And they used to advertise like crazy, especially during the Super Bowl, trying to and they never could overtake Coke. But they've I don't think they've advertised much lately, but they've dropped to the fourth most popular soft drink. But anyway, Pepsi dropped to number 4 last year. Dr. Pepper is now the second most popular soft drink in the United States. It's also the oldest soft drink. It's older than Coca-Cola. It's like a year or two older. It was back 1860s or something when Dr. Pepper was created. Coca-Cola came like a year or two later. But Coke's number 1, Dr. Pepper's number 2. Pepsi slipped down to number 4 most popular. Sprite is actually ahead of Pepsi now. More people drink Sprite than Pepsi-Cola. So that's why Pepsi's starting to advertise in the Super Bowl again, because, guys, people forgetting about us. All right, let's get to our lesson here. Let's see what's going on with all that stuff this week. Intro to computer science. Let's go to our grade screen as usual. You should have first week class assignment, the practice program, the more practice program. Those were the first 3 weeks that we did. If you got those turned in and wrote good programs, and that'll give you a nice solid start to the semester, because these are 100-point programs, those second 2. Last week was our first 5-question quiz of the semester, just multiple choice, 25 points. Now we're on more decisions. We had decisions. Now we're in more decisions this week. So let's go take a look at what that's going to involve. More decisions. So I hope you paid attention to last week's because it will be used this week as well. We looked at if statements. We're going to expand that a little bit this week because we're going to say, what if it's not true and we want to do something? Not all decisions are one-dimensional. In fact, most decisions are complex. Like take going for a walk. If you're going for a walk and your normal walking path is closed, you can either skip your walk or you might want to take a different path this time. Right? Take another path, maybe just do some yoga, climb a tree instead, whatever, something else, because you want to get your exercise in, but your normal place where you go walking is closed. Just because the first part of your decision doesn't work, that means you just quit, because that's what we looked at last week. If this is true, do that. If not, do nothing. But maybe we don't want to do nothing. We want options. So we're going to learn about if, else, and elif statements and learn how to use those to make decisions. So let's dig into that. Making multiple decisions. With if statements, if the condition is true, you take an action. If it's false, you did nothing. That's what we looked at last week. For example, if you win a race, you get a medal. If you don't win, you get nothing. You don't get a medal. So that's very appropriate since the Olympics are on right now. However, more often than not, you'll want to write programs that can handle multiple decisions. This is where the if, else, and elif statements come in handy. Check out how these two statements work. The if, else. So with if, else statements, if the condition is true, you take some kind of action. If it's false, you take the else action. Either do this or you do this. You always do something. It's just if the condition is true, then we'll do this. If not, we'll do this. So if you win a race, you get a medal. If you don't win, you get a participation ribbon. Woo! You were in the Olympics. Here you go. No, you get multiple. The Olympics is more like an elif statement. Elif statements allow you to check multiple conditions. As soon as one of those is determined to be true, the action related to that statement is taken. Like if you come in first place, you get a first place medal. Else if, that's what ELIF is. It's really else if. Else if you came in second, then you get a second place medal. Else, if you came in third, you get a third place medal. Else, you get a participation ribbon. So that's multiple things that we're checking. Did you come in first? Nope. Did you come in second? Nope. Did you come in third? Yes. Okay, you get a third place medal. Or maybe that's a nope, and you get a participation ribbon because you made it to the Olympics. I don't know that they actually get ribbons in the Olympics. I think it's only first, second, third. But LF helps us look at multiples. So depending on the program you're writing, you'll want to use decision statements that match the level of decision making you want to execute. For simple decisions, we'll just use an if statement, right? If this is true, we'll do something and then continue with our program. But if it's not true, we'll go around that and just continue the program. We won't do that. If else, if it's true, let's go do something. If it's false, let's go do something else. And then continue with our program. And then the elif, if the first condition is true, then we'll go do this and then continue with our program. But if it's false, let's check the second condition. Is that true? Then we'll go do that and then continue with the program. But if that's false, let's check the third condition. Is that true? Then we'll go on. If none of those are true, then we'll have something else down here. And it could be nothing. Maybe if none of those are true, then we won't do anything. But we have the else block that we can do and then continue with our program. Gives us lots of options this way in our programs if we can check multiple things and decide what to do based on that. So if else statements. Life would get pretty boring if you only had one option for everything you want to do. Either do it or not, right? That's why you got to make choices. Like if you want to play a game solo, you can choose to play offline. Else, you could choose to play online and play against other people. Python has a pretty easy setup for this if-else scenario. It uses Boolean logic, which we talked about last week, to determine whether a condition is true. If it's true, the program executes the block of code that follows the if statement. If it's not true, it skips that code and goes down and looks at the else and executes the code that goes with the else part. So let's take a look at this. Age equals integer input, because we know this is going to be a number. What is your age? Then we have this if else. So if age is greater than or equal to 17, print enjoy the movie. Oh, it's supposed to be a rated R film. You can't get in unless you're at least 17. Else, so let's say if this is not true, age greater than or equal to 17, that's not true. You're only 15. Then we go to the else, print, please bring a parent or guardian, because no one under 17 admitted without parent or guardian. Right? That's rated R. So this is a nice little illustration of how the if-else statement works. If it's true, we're going to print this. Else, which means it's not true, then we'll do this. So in this code, you're asking the user to enter his or her age before buying a ticket to a movie that has age restrictions. Using the if statement, Python will compare the age with the number 17, and it uses Boolean logic to determine whether or not it is greater than or equal to 17. If the age is 17 or higher, Python will print enjoy the movie. If not, basically means or else, Python will print please bring a parent or guardian. So did you know with if else statements, Python will always do something. It will take some action. It'll either do what's under the if part, or it'll do what's under the else part. It's going to do if, or it's going to do else. One or the other is going to happen. The if statement checks, is this true? Then it will do this. If it's false, then it does that. All right, let's practice a little bit if else statements. Because we're writing a program this week using if statements, so you will want to pay attention here. All right, read over the code, predict the output, run, look at the output. And then we're going to change the values of X and Y to see how it changes. So we have our main function, and we have set X equal to 20 and Y equal to 30. And then we're going to print facts about A and B, and then we're going to have an if-else statement. If X is equal, remember when we're checking to see if it's equal, we have to use two equal signs. If X is equal to Y, if that's true, print X equals to Y. Else, which means if that's not true, then print X is not equal to Y. So let's run the program. Facts about A and B, X is not equal to Y. X was 20, Y was 30. That's correct. They're not equal. So let's make them equal, see what happens. Let's make X equal 30 and Y equal 30. Oh, now it did this print statement instead, because when it checked the Boolean condition, X equals Y, it found out, hey, this is true, so I will execute the code under the if statement. Before, when X was 20 and Y was 30, this was not true, so it skipped this and executed what was underneath the else statement. Any questions? That makes sense? If this is true, then it printed this. When it was not true, it didn't print that. It printed what's underneath the else. All right, let's look at slide 2. The if else statement, define main. This time we have an input. Show equals input. When is the movie? Afternoon or evening? If show equals, and show is what we saved the input under. If it equals afternoon, then your ticket costs $5.50. It's a matinee price. Else, if you didn't type afternoon, then your ticket's $8. And it'll print what is the cost of your ticket. So let's run this. Afternoon. $5.50. I'm seeing the midnight Rocky Horror. So midnight. $8. Now notice this is afternoon or evening. I typed something else. All it checks is, did I type afternoon? If I didn't type afternoon, it's $8. I mean, I could run the program and type doggy. It's $8. It's really only checking to see, did I type afternoon? And if I type afternoon, let me run this, and I capitalize the A, I typed afternoon with a capital A, it's $8 because I did not type exactly what I was looking for. It has to be exactly what's in quotes for it to give me the $5.50 price. And let's look at slide 3. From random import. Okay, so we're using a random feature that Python has built in. Define main flips equals integer. Enter the number of coin flips. So we're going to flip a coin, and you're going to enter how many times you want to flip the coin. And what it's doing is it starts out with heads and tails being 0, and we're doing a loop. And the loop is going to go the number of times that we enter right here, flips. We're going to tell it how many times to loop. And what happens in the loop, the result equals random. If we just tell it random with no parameters, it's going to choose between 0, 0, and 1. So it's going to choose a number between 0 and 1, the random feature. So we're saying if the result is less than half, then we're going to say the coin flip was heads. And we'll add 1 to the count on heads. If it's not less than half, which means it is half or larger than half, we're going to say that it was tails. And we're going to add 1 to the count of tails. And after it's through with this loop, after it's flipped the coin the number of times we entered, it's going to come down and print the results. Here's how many were heads. Here's how many were tails. So this is using the built-in random command, saving the result each time and checking, is it less than half? So let's run this. Let's just say we're going to flip the coin 3 times. And they were all 3 tails, interestingly enough, which means every time this random number was selected, it was at least half. It was 0.5 or larger. And so it went down here and added to the tails each time. Let's flip it a bunch more. Let's do like 100 coin flips. Well, that was a lot faster. Look at that. It ended up 50-50. It randomly selected 50 numbers below a half and 50 that were half or larger. Let's try it again. I guess see. Sure, they won't do it again. Oh, see, no, this time it was 47-53. 50-50 is pretty unusual. You'd think it'd be statistically, but computers are not good at random numbers. Let's do it 10,000 times. 4,946, 5,054. Okay, I know you're all wanting to do it. We're going to flip it 1,000,000 times.
I'm getting this.
Oh, is it still? There it is, 499,261, 500,739. Just a few more tails than heads on 1,000,000 coin flips. That was a lot faster than doing it for real, wasn't it? All right, let's look at one more example here on this page. Import turtle. Oh, great. So look, we're defining functions. Remember in December, we defined a different function. This defines a function called draw face. And so this code here draws a face. And then we created a different function, define a function called draw eyes. And so this part of the code draws eyes. There's one eye, here's the other eye. Now we have another function that we've called draw a frown. And this draws a frown. And then we have a function called draw smile. And this draws a smile. Now here's our main function. Here's what actually runs. When we go down to the bottom and we say run the main function, we create our turtle. We set him to a speed of 10. Yeah. And the first thing we do is we go up and we run the draw face. So it goes up to the code up there and draws a face. Then it goes up to the other function and draws some eyes. So after it draws the face and after it draws the eyes, then it stops and has an input statement. It says, do puppies make you smile? Y or N? Yes or no? If you choose yes, the Y, then it will go up and it will do the draw smile function. If you don't choose Y, it's going to assume you chose N, and it's going to draw a frown. Let's run this and see what it does. Okay, look, it has drawn, it didn't finish coloring in the eye, but that's the next thing I do. It has drawn the yellow face, and it's gone through the eye function up there. Now it stopped and said, do puppies make you smile? And if we hit Y for yep, then it went up and chose the smile function. Smile, draw smile. Notice we never ran this one, draw frown. It never ran that function. Let's do it this time. We'll say N. Now it drew the frowny face. And it did not do the draw smile this time. Let's go see why. So our code says if smile equals yes, do this, else do this. So there's no way it does both of them. It's an if else. You either do this or you do that. If you put Y for yes, it's going to do this. If you didn't put Y, that's false. It does that. It doesn't do both. It doesn't do both. All right, let's go to page 4. Now we're going to look at the elif statements. This is going to be critical to our program this week. Sometimes you need more than 2 options, not just this or that. This is where the elif statements. Think of it of a combination of the words else if. Elif is else if. In an elif statement, you can allow for a wider range of possibility. Here's an example. Grade equals input. What is your grade? So you put in A, B, C, whatever it is, right? If grade equals A, print excellent. Elif, else, if it doesn't equal A, does it equal B? Print good job. Else if maybe it doesn't equal A and it doesn't equal B either one, does it equal C? Nice start. Try to study more next time. Else, now we got an else. You end with an else. You got if, else if, and then the final thing, if none of those are true, please reach out to your teacher because you're not doing well. So this is good to study because you're going to need something like this in this week's program. Here you've asked the user to input his or her grade. Python will compare the response with A, B, and C in that order, one at a time, and use Boolean logic to figure out are any of those true. As soon as it finds a match that is true, it'll stop checking and it'll print the appropriate response. In other words, if you enter A, this code is going to check right here, print that, and then skip to the bottom. It's done. It's not going to look at any of the rest of that because this was true. I don't need an else, or an else. I don't care about else if, or else because this was true. All right. With else if statements, Python may or may not take an action. Do this if that's true. Do that if that's true. Do this other thing if that's true. Otherwise, maybe none of those are going to happen. So we'll just do this thing down here because nothing is true. Like if you entered M as your grade, well, that's not A, that's not B, that's not C. It doesn't do any of those. It comes down here and just does the last else. The else is the catch-all. Anything that's not true above, we're going to just automatically do this down here. All right, let's look at this. Here's the facts about A and B thing again. All right, so we set A equal to 10, B equals to 200. And we're checking several things about A and B. If A equals B, then we're going to print that. Else, if that's not true, if this is not true, is A greater than B? Let's check that. If A is greater than B, then we'll print that. A is greater than B. But if they're not equal, that's not true. A is not bigger than B. That's not true. A is less than B. Print this. And if none of those are true, if A and B are not equal, A is not bigger, A is not smaller, print there was an error because that's the only three choices. If we're comparing two numbers, either they're the same or one of them has to be bigger than the other one. So somewhere there was an error. So let's run the program. A is less than B. That's the one it chose. This one here, the last one. So this was false. They're not equal. This was false. A is not larger. This one is true. A is less than. If we look at it, A was 10, B was 200. So that's true. It got to the part where A was less than B, and that's the one it chose. It says change the values. Let's do this. Let's make them both 200 now.
Oh, that one?
A is 200, B is 200. We expect the very first if statement should be true, and it'll skip everything else. A equals B. It did that, and then it skipped everything else. How about making A 200.00001? This is 200.00001, and this is 200. A is greater than B. That's true. It is. Barely. What if we just do this? Make it 2.0000. How do these compare? A equals B. See, didn't fool it. 200.00000 is the same as just a 200. All those zeros don't make any difference. A equals B. All right, let's look at the next one. Define main. Print. Who won the game? Here's your score. Here's my score. If your score is higher than my score, then you win. We'll print that. If your score is less than my score, I win. Otherwise, it'll just assumes we tied because that's the only three choices. Either you got a higher score, I got a higher score, or we have the same score. So it doesn't even have to check anything. It just says else. Because if this is not true and this is not true, then this must be true. I win, so win the game because my score was 99.05. Yours was only 95.20. So here, we'll make yours 99.20 now. Let's run it again. You win. All right, let's raise my score up. Oh, we tied. So these if-else statements, you can see here is a real good example of how an if-else statement works. Either this is true, or neither one of those is true, and it'll automatically do what's left. Okay. All right. Let me talk about this real quick before we look at this last Python God activity. This week's program, we're going to use Turtle Graphics. And your program is going to allow the user to draw something with a turtle when they enter something on the keyboard. Like if I hit 1 on the keyboard, maybe the turtle draws a star. If I hit 2, maybe he draws a circle. If I drew 3, maybe he draws a square. Or maybe it's just a simple thing where when I hit 1, the turtle moves forward. When I hit 2, the turtle turns left. When I hit 3, the turtle turns right. Maybe hit 4, maybe he goes backwards. I don't know. And I can just have to go 1, 2, 1, 2, and I can just make him keep going forward and turn in, something. But you've got to write a program to where the user enters a button and you're using if and elif statements to see what they use. Did they enter 1? Did they enter no? Did they enter 2? No. Did they enter 3? Yes. So what do I do when they enter 3? Turtle turns right 90 degrees. That's what we're looking at. Okay. So do not just copy this. I have every year students just copy this and all they do is change the color and turn it in. If you just change the color it uses, you didn't write any code. You just took the code and just, instead of turning left 90 degrees, you turn left 100 degrees. There it is. Here's my program. No, you didn't write a program. You stole this program and just changed it to turn 100 degrees instead of 90 degrees. Don't do that. You can steal from this program in the fact that it's got a menu built in. Copy the menu part. It's got if-else statements. You can look at those and use those if-else, but you need to change what it does. Actually write some code. Right? If it has it draw a star, write different code. Have it draw a circle. Have it do, substantially change the program to where it's your program. Because when I get this and I say all you've done is just change numbers and change colors, but otherwise it's really the exact same program, you don't get credit for this program. And I have students do that every single year. I'm just going to change the colors, change numbers. No, you need to change enough to make it substantially your program. Right, to where I'd go, oh, that's pretty cool. Oh, that's different. That's pretty neat. Oh, well, that looks just like the one in the lesson. Don't do that. You want to get credit for this. We got a good start going. You should already have a lot of points for the programs we've written. Don't check it out now. And if you need help, come see me. All right, let's look what this does. It has defined a function called sunburst.
You're good.
It picks the pin up. It moves to this position, 150, 130. Think of it like an XY coordinate. And it says I'm going at a position of 270. Think of that like a 360-degree circle. 270, it's going straight down. It sets the pin down, makes it gold colored, and then draws this little sunburst star.
Thank you.
That's what this function does. So if you want to define a function like this, if it doesn't make a sunburst, don't call it sunburst. If you want to make this a circle, define circle, have it make a circle. And change this code where instead of drawing a star, it draws a circle. Here's another one, spiral twist. This function, now see, they stole from their own program. It does not draw an eye. It draws a spiral twist. So their code, this is wrong. They didn't change their comment. They stole the other program and just did part of it. But now it makes it blue, picks the pin up, moves to this position, and puts the pin down. Does a loop, goes forward and left 91. Makes this spiral twist. It loops 0 to 75 going by twos. So we'll look at that in a moment. Here's another function called doily. It does not draw here. I'm going to change this. It's driving me crazy. It draws a doily. It doesn't make a frown. Pick your pen up, move over here, turn left, put the pen down. And it does a loop inside of a loop, inside of a loop. There's another 4 in there. There's 3 loops to draw a shape. Here's, like I say, if you want to take this part of the program to have a menu already built in, you can do that. Just change what the menu says. This is if you type 1, it draws a sunburst. If you draw 2, it makes a spiral twist. 3, it makes a doily. 4, exit. You got to have that exit option. If you don't have an exit option, you'll get stuck in the program. So if you want to take this part of the program, but you need to change this. 1 is a circle, 2 is a square, or 1 moves forward, 2 turns left, 3 turns right. Whatever you want to do. So that is just the print menu function. And then finally, here's the main function. Main function is way down at the bottom. So when it runs main, it's going to start right here. This is where the program starts with the main function. It's going to create the turtle. It named him T. That's pretty boring, but T, and sets him the speed of 10. And here is it's going to use a while loop. They're using a while loop. They set the choice equal to -1 first because they're waiting on the user to choose something. So they're using a while loop because 4 is an exit. So they're saying while the choice is not equal to 4, because if you choose 4, it should exit. Your program should be done. So they print menu, and then they ask the user, look at the menu, which item would you like to draw? Now, there's a problem with our Python is it doesn't show us the menu first, but it will after the first time. What would you like to draw? If the user types in a 1, it will draw the sunburst. See, it goes up to that function. If you say 1, I'm going to send my turtle up to draw the sunburst. If you don't say 1 and you choose 2, I'm going to send the turtle up to draw the spiral twist. If you don't choose 2 and you choose 3, I'm going to send the turtle up to draw the doily function. If you choose 4, it's going to exit. Thank you for drawing here today. It's going to come back up here. It's going to say, oh, the choice does equal 4. That's the end of my loop. And that's the end. So let's run this and see how this works. In fact, I think I'm going to, let's copy it and put it in our idle window because I can make a bigger screen that way. Here's our code. Got all these functions. It does different things. When we run it, look at the menu. Now, unfortunately, our version did not print the menu. So the first time I'm just going to hit 1. Oh, it's drawing this little yellow sunburst over here. And when it gets through drawing that, it comes back to the menu. Now I can see the menu because it printed it. 1 is the sunburst, 2 is a spiral twist, 3 is a doily, 4 is the exit. So it's like, okay, now I want a doily. I'm going to hit 3. 3. It's drawing yellow and green. There's some yellow mixed in there, but this is the doily it drew. That's what they named it. They named it doily. And when it gets through, it comes back here. Why does it keep coming back here? Because I have not chose 4 yet. 4 is exit. If I don't choose 4, if I hit 4 now, program's done. It ended. We got here. I chose 4. The while loop says while choice is not equal to 4, keep looping. Well, I chose 4. So it now ends. That's the end of the program. I drew 2 things. The sunburst and the doily. I never chose number 2. I can run it again. 1. It's going to draw that sunburst. Now I'll choose 2. Let me draw 2. Oh, that's a pretty cool spiral twist. 3. There's the doily. If I want to draw 2 again, I think it'll draw it on top of the old one. Let's see. Yeah, see, it's going to draw it right on top. Oh, it's a little different this time because it's pointing in a different direction. But I drew a doily on a doily. 4. And exit. All right. That is the end of the lesson. Let's go look at this actual template. In Google Classroom, if I go to Do This Week in Buzz, there is the AI tutor that will help you do this if you want. But here is the template. More decisions. If you click the tutor, you won't be able to type on it. So make sure you go to the template. Do you need to review how to do turtle graphics? Here's a link to that video, that 10-minute video on how to do turtle graphics. If you need to review that, I'll put it right there at the top of the template. But here it is. Write a program to move the turtle based on the user's request. Move it and make a circle. Move it, make it square, whatever. Comments, name, date, purpose. Make sure you indent things properly, meaningful variables. Create a menu that gives the user options for moving the turtle. The menu should contain letters or numbers. Like you could say F instead of 1, you could say F equals forward, L equals left, R equals right, if you want to do that. Use at least one if else or elif statement. And it should be used to move the turtle based on what the user did. You'll have to do that. A loop is optional, but you may need a loop depending on what you do with the turtle. Like they use loops to draw doily shapes and stuff. But if you're just doing forward, left, right, stuff like that, you don't need a loop. You may need a loop for the if else because you may want to loop back so they can keep doing that. And make sure you use one color other than black. You can use black on your drawing, but do some other color as well. So write your pseudocode. Figure out what your menu is going to do. Figure out what your turtle is going to do. Write your pseudocode. Here's an example of what someone else did. This is pretty clever. Here's their menu. Let me see if I can make that bigger. Here, make it really big. To move the turtle, F was forward, B was backwards, L was left, and R was right. And then Q was quit. So there was the choices. And it says, try to move the turtle to the pond. So your turtle started over here. They actually showed the little turtle. And so the person hit forward, 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 left, right, left, forward, right, forward, and into the pond. Then they quit. Hey, I got the turtle in the pond. So their computer drew this little pond. The program drew this little pond and then put the turtle on the screen. And then the user had a little game. Forward, backward, left, right. I got to get my turtle in the pond. So you can do that. You can just make a little game if you want to. Put the turtle in the pond. The main thing that is being graded in this program is, can you use the menu with if else statements, if else statements, to where the user controls the turtle. Oh, we don't have to put the code here. Turn in the code. Turn in the .zip file in Buzz. Yeah. I originally used to have it put the code here, but you don't have to. You can turn it in Buzz. You can include a screen. I won't take off if you don't give a screenshot, because I'll run your program to look at it. But if you want to do a screenshot, I put that option on here. Put your screenshot so you can show what yours looks like. And then don't forget to answer these questions. This is worth 20 points right here. All right, guys. Have some fun with this. Draw what you would like to draw. The main thing is use the if statement so that the user can choose what the turtle does, or what shapes draw and which ones they don't want to draw based on your menu. So if you have any trouble with this, come Wednesday, I'll be here. Email me. We can set up a time later if Wednesday doesn't work for you. But we'll see you next time. Check RTI to see who has to be here Wednesday.